Good morning. It's wonderful to be back here at EclipseCon and see so many familiar faces and so many new faces here as well. This morning, I want to talk with you a little bit about digital autonomy, because this is a very, very important topic that's happening across Europe right now, but not just in Europe, but really across the world. The reason for that is that, as we start to take a look at technology, I think everyone is starting to realize how important it is and how fundamental it is in terms of everything that we do. But along with that realization, we also see that we've got to be able to support a lot of safety and security and also business impacts in terms of how do we use these technologies. And so, for example, here in Europe, there's a lot of ideas and initiatives in terms of how do we start to promote local European digital sovereignty using a combination of different regulations and different technologies. So, for example, you've seen new laws such as the Digital Market Act or the Digital Services Act, which are all focused on how do we create safe online environments? How do we make sure there's fair competition across all these things that are going on? But what I want to talk about today is that I think that one of the key ways that we can really start to enable people to have real digital autonomy is through open source. And a lot of the work that we're doing here together within the Eclipse Foundation can actually give us a very strong foundation for how do we work together to promote our technologies, but also a lot of digital autonomy and digital sovereignty across our environments. So the first area that I want to focus on is across mobile devices. These are perhaps the most important technologies that we use and that we carry with us, and it's one of the first things that we think about when we think about what is important from a digital autonomy standpoint. Now, as we know, when we first started with digital devices, it was all about the phone. We carried the phone with us, and that was the primary way that we interacted with these mobile devices. But over the last several years, the market has really changed. And what we've seen is that there's been a whole range of new different devices, from an IoT standpoint, that all need to connect together. So you've got things like smart TVs or smart cameras and smart speakers and your laptops and your tablets. And they all need to connect and they all need to work together to deliver a really nice experience. The problem, though, is that for devices to work together across these IoT ecosystems, they all have to connect through the cloud. And there's really only two cloud gatekeepers in terms of controlling the ecosystems across IoT devices. So even if you've got your smart TV and your phone, and they're just a few centimeters apart from each other, they have to go through a cloud connection before they can talk to that other device with you. And this is a big problem. It's a problem from an efficiency standpoint. It introduces a lot of latency. It's not so great from a security standpoint to be able to have to create all these cloud connections just to have things work together. And it's also not so good from a digital autonomy standpoint because you've got a couple of different clouds that control the entire ecosystems in terms of how things work together. So one of the things that we've been working on here at the Eclipse Foundation is a new open source operating system called Oniro. Now, Oniro is an open source operating system focused on the distributed device market. And one of the innovations that we've been building in Oniro is that it's distributed across different devices. So we can build direct point-to-point connections and virtualize what are the different attributes of a device and combine them together. So if I'm at home, maybe my speakers, can be my actual stereo system. My screen can be my TV. My compute can be on my phone. I move into my automobile. I can change it to my in-dash operating system. Everything can connect locally and change on the fly. And we think this is a much better approach, especially from a digital autonomy standpoint, because this allows you now to be able to be in control in terms of how you work with your devices. Today, when you start to take a look at what devices do I want to work together, I've got to think about, is it in this ecosystem? Is it in this ecosystem? How do I start to build applications across them? I've got to build a dedicated application for each device that I'm going across. With Oniro, because it's a distributed application, I can just write it once, and it'll work across all my devices. And now, me as a user, I have a lot of choice in terms of what devices do I want to use, and how do I start to experience everything really in terms of my requirements and my use cases. So this is one of the things that we're really excited about from a digital autonomy standpoint, because we think that building this in open source here at the Eclipse Foundation can start to open up a huge new ecosystem in terms of how devices can start to interoperate together. So for consumers, this is a really, really powerful new solution because it allows them to have choice and flexibility and control over what devices do they use and what happens with their data. For a lot of the different device manufacturers or silicon vendors and so on, this is a completely open source operating system. It's not controlled by one of the commercial vendors because it's here with the Eclipse Foundation. And so whether you're a very small company or you're a very large company, it's available for you to start building your devices. And for software application developers, this is a huge win as well. The situation with most devices today is, I'll have an operating system for my tablet, another one for my laptop, another one for my phone, another one for my TV, and so on. I have to write a different application for all of these environments. With Oniro, I can just write my application once and deploy it across all these different devices, and they automatically work together. So this is a big improvement, we think, from a device standpoint. Now, I want to go to the other end of the spectrum, which is around cloud. And cloud is probably the other really, really hot topic, especially here in Europe, when we think about digital autonomy. And we see a lot of both regulations as well as industry associations and projects all focused on how do we start to deal with cloud computing and start to drive a lot of more open capabilities from a cloud computing standpoint. So why do we see all this strong interest? Well, the first reason, I think, is that when we take a look at the state of what does the cloud market look like, whether here in Europe or elsewhere around the world, what we find is that there's a few very, very large clouds, hyperscalers, that sort of control the market. And then we've got a number of very, very small clouds. So here in Europe, we've got a number of different regional clouds, some telco providers, and so on, all providing cloud services. But the challenge is that, compared to the very, very large clouds, it's very hard to be able to offer the full range of services and capabilities and grow market share. And so this is one of the things that everyone is taking a look at, from a digital sovereignty and digital autonomy standpoint. Do we want more flexibility so that we don't have to have an environment that is just concentrated in a very, very few large set of cloud providers? Well, if we want to start to open this up and start to take a look at what would a future look like, I think there's a couple fundamental problems that we need to address from the industry standpoint. I call these lockout and lock-in. Let me start from a lockout standpoint. So if you think about why do people go to clouds, the main reason that they go is to get the services that are available in the clouds. Maybe I want a database as a service or a container as a service, and AI, machine learning training capability as a service, and so on. Now, if I'm a cloud provider, I provide these all as managed services. If I'm a software provider and I want to bring my capabilities into a cloud, though, I have two routes to market. The first is I can create a software image to put into the cloud. So this could be a virtual machine image, it could be a container image, but this is highly limited in capability compared to the managed services because from an enterprise customer standpoint, I will be responsible for installing it, configuring it, operating it, securing it, and so on. I don't have to do any of that work with the managed service. It's kind of just point and click, and it works for me. So the way a lot of software companies have been addressing this is they move to a software as a service model. We've got a lot of popular SaaSes that run in clouds. It could be something like a MongoDB Atlas or a Confluent Cloud or a Red Hat OpenShift and so on. The challenge, though, is that even with all these SaaS applications, they could be running in the exact same physical data center, but they're all highly isolated and limited in functionality compared to a managed service. For example, if I just take 3 SaaS applications in the same data center, I've got to go to 3 different websites. I have to have 3 different accounts, 3 different billing systems, 3 different network spaces, 3 different data spaces. They don't work together very well, and they certainly don't integrate with the native services on the cloud provider. On the other hand, if I just go into the cloud providers, native services, everything integrates, everything works as it should be. And so the ecosystem is fundamentally locked out from being able to create managed services. And this is one of the reasons that the very big clouds have so much control is because they're the only ones who can offer these service capabilities. So that's the first big challenge that we see from a cloud standpoint is really that only cloud service providers have the ability to create managed services, and they lock out the rest of the ecosystem from being able to provide the same capability. Now, the way that a lot of enterprises have been trying to deal with this is that they're all going multi-cloud. You can see that basically every single enterprise has a strategy in terms of how do I go multi-cloud or hybrid cloud and a combination of that. The challenge, though, is that if you really want to go multi-cloud, services are not portable across clouds. If I go to, just to pick on AWS because it's the market leader, and I start using AWS Lambda, I'm basically stuck in AWS because Lambda does not exist in any other cloud. If I go to Azure and I start using Azure Batch AI, I'm stuck in Azure because that service does not exist in another cloud. And so from a customer standpoint, we've basically got to make two choices. One, do I go least common denominator across the clouds if I really want to go multi-cloud, or I have to specialize. I use this cloud for that set of capabilities, this cloud for that set of applications, but they're not really working together. And the reason for that is that services are not portable from one cloud to another. And this creates a huge, huge point of lock-in from a cloud standpoint. So if we really want to start to address this, we've got to think about the fact that services are largely locked in and not available from cloud to cloud. And this has a huge impact, not just on service and processing capability, but across data as well. A lot of people think, if I could only just export my data from one cloud to another, that would give me a lot of flexibility and a lot of digital autonomy. The problem, though, is that most data in clouds is highly coupled with the processing service in terms of how do I use that data. So if I could export all my data from Amazon Redshift into Google Cloud or Open Telecom Cloud or OVH Cloud or pick your cloud, it doesn't do me much good because AWS Redshift is not available in any of these other clouds to process that data. And so the fact that ecosystem vendors are locked out, the fact that my services are locked in and not portable, this creates a really, really strong point of lock-in, both in terms of my computing architecture as well as in terms of the data that I want to use. So we're starting a new initiative here at Eclipse Foundation called Open Services Cloud. This is the first time we're talking about it publicly here. So I'm very excited to explain to you what we're looking to do. But what we want to do is to fundamentally open up the cloud services layer so that we can start to unleash a real open managed service ecosystem across the multi-cloud. So how do we do that? Within every single cloud provider, there's a set of internal capabilities in terms of how do I take software and turn it into a managed service. These are things like how do I do identity, how do I do billing, how do I do console access, how do I do placement, how do I do metering, and so on. Every cloud has them. Every cloud keeps these private to themselves. It's the only reason cloud providers can provide managed services and no one else, because they don't have access to these APIs. So the first thing that we're going to be doing within the set of members across this initiative is we are going to open up access to these APIs for the first time, including at my own company's cloud, Huawei Cloud. And so a third party will be able to come in to our clouds and create a native managed service, no different from the set of managed services we cloud providers can offer ourselves. And so this will address the lockout problem. Software providers will be able to come in and create managed services. But how do we deal with the lock-in issue? So in order to address lock-in, we're creating a new open source framework that will do a few things. The first is we will define in open source what are the set of APIs and capabilities a cloud provider must expose in order to be able to allow managed services to run in the environment. Then we will bind this open source framework to the native APIs across the different cloud providers. So that means if I'm a software vendor, I can write once against this framework, and now I'm a portable managed service across a multi-cloud. And so this addresses the lock-in problem. So with Open Services Cloud, we're very excited because we think that we can start to address a lot of the fundamental challenges that we have around cloud computing and really start to enable this new open ecosystem around managed services and enable a real multi-cloud environment here in Europe. So as we take a look at digital autonomy and a lot of the things that we're doing, as I mentioned before, open source is one of the best ways in order to give ourselves that kind of autonomy and flexibility. Whether you're looking at the device that you carry with you or that you live with, or you're looking at the other end of the spectrum in terms of your cloud computing capabilities. Doing things in open source, doing things under open governance with the Eclipse Foundation, we think is a fantastic way to innovate, to build these technologies, but to do so in a way that everyone is in control of their own destinies and of their own futures. So if you'd like to learn a little bit more about some of the things that I've spoken about, we're actually highlighting a lot of these this week at EclipseCon. So I'll just call out 3 high-level things. One, you can come visit our booth outside. We've got a nice booth where we'll be talking about a lot of the things I mentioned today, including Oniro and Open Services Cloud. We've got a number of other talks that will be happening here. And then for Open Services Cloud, we actually have a birds of a feather tonight. So we will have a 2-hour meeting where we will deep dive into this, and we'll be providing free dinner and drinks in case you have nothing else to do tonight and you'd like to come and join us. So thank you very much. We look forward to engaging with you and collaborating with you here at EclipseCon, and really appreciate the time to talk with you this morning.